Okay, this is a continuation of division of polynomials, and we're looking at long division of polynomials now after the introduction about the algorithm for long division. So as you'll see behind my head here, I'm going to move out of the way so you can see the division of polynomials, the title here, and that there are two conditions, and we'll talk about those after the initial example, but I want you to get it in your notes if you're taking notes from the video. So the first condition is descending order. And by the way, this is descending order according to the degree of terms. And you always start with the highest and go to the lowest. So this has to do with degree, if you remember from our first lessons on polynomials, that we talked about the degree of a term determining the degree of a polynomial. Okay. Also, another condition is if we're missing a term in the descending terms in the line, you need to have a zero placeholder. I'll tell you more about that later, but let me just say, for example, here, this one we're going to use just a moment, but notice that I have 10x squared plus 5x minus 8. This is a degree 2, degree 1, degree 0 term. And if one of those terms, like 5x, if that was missing, you would need to put a 0 into the problem. So I'll tell you more about that, and we'll look at some examples in just a minute. Okay? So I'm going to erase part of this and show you that when you're given a problem to do that's asking you to use long division, it'll come looking like this. We're going to set it up using the long division symbol, the same one that you use with numbers. Okay? So the top number, the numerator, goes inside. So the numerator goes inside in descending order, and the denominator goes on the outside, okay, also in descending order. All right. So I put over here just a little prompt to show you the procedures, and we're going to use those for some scratch work. All right. So the very first thing you're going to do, which is similar to numbers, is we're going to look at 2x minus 3 going into this polynomial, but the actual procedure is going to involve just the first two. So what we're doing is we're looking at 2x into 10x squared, and my goal when I put a number up here and multiply is I want 10x squared to show up when I multiply. The way we go about that is we're going to take the inside 10x squared and divide by 2x. This will help us get the top term, okay? So 10x squared divided by 2x is 5x, okay? I circled it because it's going to go up top. Now, we're also going to use columns as we go. For example, this is going to be the degree 2 column. This will be the degree 1 column and the degree 0 column, okay? So 5x is going to go above the 5x that's here. They have nothing to do with each other except they're the same degree. Okay? So after we divided 10x squared by 2x, we found 5x, which goes here. Now the next step is to multiply. So we're going to take 5x and multiply times the entire divisor, which is two terms rather than one term, like when we're using numbers. And the 2x minus 3 is just what I'm showing here because it's scratch work. And you're going to distribute. Now, when you distribute, your first term is 10x squared, like the one above it, minus 15x, okay? So you put this right here, 10x squared minus 15x. Now, the next step is going to be subtraction. And I'm going to use a red pen for this. And the reason I'm doing that is I'm drawing my line in red to remind me that I am subtracting two terms instead of one term. Therefore, I have to distribute the negative. Okay? So when I do that, it's going to distribute to 10x squared, make it negative. So I'm going to circle it. And it's going to distribute to negative 15x, and it's going to make it positive. Now, most people, when they're taking notes, are using pencil, not colored pencils or pens, and cannot distinguish what was original and what was next. And that's why I recommend that you circle the changes. So subtraction caused these to change sign. This became negative and this became positive. from the multiplication step, okay? So subtraction changes their sign, and then you combine like terms. Now these right here are going to cancel 10x squared minus 10x squared, which is what we want. That's what our goal was and will be every time we go through the algorithm. Now, however, though, I have 5x plus 15x, not minus, because subtraction changed the sign, and the next step is to bring down. So I'm bringing down -8, but I'm going to start all over again, and division is now going to be 20x divided by 2x to determine what goes up top. So 20x divided by 2x is going to give us 10. I circle it because it goes up top. It's a positive 10. Notice that I'm putting it above the column of constants, degree 0. So 5x plus 10 is up top. Now it's time to multiply. Remember that we're multiplying all the way through the entire divisor, which is two terms, 2x minus 3, which gives 20x minus 30, okay? Usually underline those just to distinguish the difference. So 10 times 2x minus 3, and the result goes here, is 20x minus 30, but it's time to subtract. So I came up with a little reminder on changing your sign. And it rhymes, but you have to do it with a little Texan accent. So draw your line and change your signs. Draw your line and change your signs. I know, it's silly, but sometimes silly is what you'll remember. Okay, so draw your line, change your signs, which indicates the subtraction step. Okay, so we're going to subtract now. 20x minus 20x gave us what we wanted, nothing, it cancels. But -8 now is added to 30, or 30 minus 8, whichever way you want to look at it, is going to give us a positive 22. Now, the answers are going to be in proper form. They're not going to just say, hey, here's the quotient and here's the remainder. They want it in this form. If this is a positive 22, you need to have a sign here that indicates the top or the numerator sign, which is 22, and then over the divisor, which is 2x minus 3. If you have any questions on how to write this answer properly, just let me know. But remember, between the quotient part here and the remainder fraction, there needs to be a sign. And that sign is dependent on whether or not the remainder in the numerator is positive or negative.